Hello students, today we are going to have a discussion on question number 24 that was asked in Pabson Chitwan pre-SE 2076. So the question goes like this: PQRS is a cyclic quadrilateral. Side PS and QR are produced to meet up at a point T outside the circle. If PQ is equal to RT and arc PS is equal to arc RS, prove that angle PRQ is equal to twice angle RTS. So this was the question that was asked in pre-SE 2076 Pabson Chitwan. So here we are given a PQRS is a cyclic quadrilateral, so we need to draw a circle, and inside it we need to draw our cyclic quadrilateral. So let's draw it. So you can see here I have drawn a circle. So here we have drawn a cyclic quadrilateral PQRS, and here in this cyclic quadrilateral PQRS, here the sides PS and the side QR is produced to T. So this is the figure. Now let's move on the solution. So first of all, before starting the solution, first of all let's have a look out on what are the tricks that we are going to use here. So here, since it is all about this question from circle, so first of all let's recall about the properties that we have read in circle. So the first property, if any two arcs of a circle are equal, then the chord opposite to them are also equal, and vice versa. So here you can see if arc AB is equal to arc CD, then you can say AB is equal to chord CD, or vice versa. Means if chord AB is equal to chord CD, then we can say arc AB is equal to arc CD. So this is the property that we have read here. Similarly, the inscribed angles half of central angle standing on same arc. Similarly, inscribed angles on same standing on same arc are equal, and similarly the opposite angles of cyclic quadrilateral are supplementary, and if side of cyclic quadrilateral is produced, the exterior angle is equal to the opposite interior angle. So these are the properties that we have read here in circle. So out of these properties, let's see which of them are applicable here. So here, since you can see here those two arcs PS and SR are equal, then you can say PS is equal to SR. So this is the first property that we're going to use here. So the next one is, so here we need to prove that this angle PRQ is twice angle STR. So this is to be proved here. Regarding this angle, this is the inscribed angle. So PRQ lies on the arc PQ. But here, regarding angle STR, it's not an inscribed angle, neither it is central angle. So besides the property of circle, here we need to move on the property of congruency also. So in order to use this property, PS arc is equal to SR arc, here we need to draw a construction that is QS. So here we are going to take two triangles, triangle PQS and triangle ESRT. So here the reason behind that we are taking these two triangles is, here if we become able to show these two triangles are congruent to each other, then we can say ST is equal to SQ, and if we become able to show these two triangles are congruent and QS is equal to ST, then we can say this angle is equal to this angle, being base angle of isosceles triangle, and this angle plus this angle gives this angle, because this is the exterior angle of the triangle QST. So all of you look at these two triangles. So in these two triangles you can see side PQ is equal to side RT. Similarly, side PS is equal to side ESR. Now just we need an angle, and here the angle that is made by the side QP and PS is angle QPS, and here ESR and RT mix angle ESRT, and these two angles ESRT and angle PQPS are equal, because we know the exterior angle of cyclic quadrilateral is equal to opposite interior angle. So by that property we can say these two angles are equal. So here we have taken these two triangles, triangle PQPS and triangle ESRT. So here you can see PQ side is equal to side RT, that is given in the question. Similarly, this angle QPS is equal to angle SRT, because this is the extra angle of cyclic quadrilateral and this is the opposite inter angle of cyclic quadrilateral, and the relation is they are equal to each other. And lastly, this PS is equal to SR. So they are equal because they are the curved opposite to equal arcs. So being arc PS is equal to arc PS is equal to arc RS. So that is also given in question. So in this way, here we have proved these two triangles are congruent from the axiom SAS side angle side. So since these two triangles are congruent, so here the side that's opposite to angle QPS is QS, and the side that's opposite to angle SRT is angle side ST. So we can say QS is equal to ST, that we have mentioned in question statement number 3, being corresponding sides of congruent triangle. Now let's move on to statement number 4. Since the sides are equal, this triangle becomes an isosceles triangle SQT. So we can say these two angles SQR and STR are equal to each other, because we know the base angles of isosceles triangle are equal. Now moving on the next step, here we can see here, so in this triangle QST, here the angle PSQ is the exterior angle, and we know the exterior angle of triangle is equal to the sum of opposite interior angles that we have done here in step number 5. And here, since these two angles are equal to each other, we have seen here in step number 4, so we can say angle PSQ is equal to twice angle STR, because these two angles are equal to each other. So here the reason is the relation between extra angle and opposite angles, interior angles of triangle. And lastly, this angle PSQ and this angle PRQ, they are equal because they are the inscribed angles on the same arc PQ. So here from statement 5 and 6 we can say, instead of here PSQ, we can replace it by PRQ. So we can say angle PRQ is equal to twice angle RDS. So this is all about this question number 24 that was asked. So let's hope we will be meeting soon in next video. Thank you.